and from that we can see discuss the convergence. Is screen visible? Yes.
Yes, sir.
Okay, so yesterday I gave you some problems for your practice or exercise. Did you solve them? Yes. So for example,
Sir, can you tell the first one?
So recall this. These are the important techniques we learned last time. So if series AN is convergent, then limit AN is 0. That is, if limit AN is non-zero, then series AN is divergent. This is the divergence test actually, right? Secondly, what we P series test. So what is P series test? Series 1 upon n raised to P is convergent, right? If P is greater than 1, is divergent if P is less equal 1. This is what we learned last time. Now third comparison test. So what is a comparison test? So given series AN and series BN, and suppose this series satisfy the condition AN is less than or equal to BN. So there exists K such that AN is less than or equal to BN for all n greater equal K. That means after some K, all infinitely many terms of BN are less equal corresponding terms of AN. Then if series BN is convergent, implies AN convergent, right? And second, AN is divergent, implies bigger is divergent. Correct. So this is what we learned last time. For example, so let us think about the example or problem which I gave you yesterday. Right? What was the first problem? E to the power minus n. Am I right? N is from 0 to infinity or 1 to infinity. So what is my term here? An, nth term of the series. E to the power n, 1 upon e to the power n, right? Is it correct?
Yes, sir.
Right. So now you look at 1 upon n square. So let Bn is equal to 1 by n square, right? Okay. Now I want to check what is A1. What is A1? A1 or A0 doesn't matter. Look at A1. Let us start from 1 to infinity. So what is A1? 1 by E, correct? B1, 1. Now compare A1 and B1. Which is bigger, which is smaller? A2, 1 by E square. And what is B2? 1 by 4. Now compare which is bigger and which is smaller. Which is bigger, which is smaller? You tell me.
A2 is greater.
A1 is smaller than B1, correct? A2 is
Yes,
smaller
sir.
than B2, right? A3 is 1 by E cube, and what is B3? 1 upon 3 raised to 2, that is 1 by 9. Now, can you prove that? So, in general, is it true that 1 upon e to the power n? Okay, before that, e to the power n is greater than n square. Is it true?
Yes, sir.
Right? And therefore, can I say that e to the power 1 upon e to the power n is less than 1 by n square for all n? Is it right?
Yes, sir.
Therefore, what is the situation? An is less than or equal to Bn for all n or n greater equal 1. What is k here? 1. Right. And therefore use the comparison test. Use comparison. What comparison test says? If corresponding terms are smaller, if Bn is convergent, certainly An is convergent. And if An is divergent, certainly Bn is divergent. So this is what relation. So now you observe this and what we can predict from this. So we have, what is series Bn? Bigger. What is series bigger series? 1 by n square. Is convergent,
Yes, sir.
right? So why it is convergent?
P is greater than 1.
P is greater than 1. And therefore, by comparison test, what we can say?
An is convergent.
Right. 1 upon e to the power n is convergent. Right. So this sum is definitely finite, no doubt. In fact, you can look at this series in alternative way. What is alternative way? Do you see alternative way? Series
We
AN.
can compare it to 1 by 2 raised to n.
Yes, or you can actually 1 upon e to the power n. Right. N is equal, n starts from 0 to infinity or 1 to infinity. That is not an issue. Because if you add one more term, that is just addition of, if sum is finite, adding some finite number still finite. Okay, it is like, is it like series r to the power n? Geometric series? Yes.
Yes, sir.
And what is r in this case? 1 by e less than 1. Therefore, what is the sum? You can actually calculate the sum 1 upon 1 minus r. What is it? Right? So e upon e minus 1. So actually the sum is this irrational number basically. Correct? Yes. Is it clear?
Yes, sir.
Uh, the second example which I gave you yesterday, key 1 upon n square plus 2n. What is an? 1 upon n square plus 2n. Now, can you find a bigger series which is convergent so that we can say that smaller series is convergent? Is it possible in this case?
1 upon n square.
1 upon n square. So this is less than 1 by n square, right? Because denominator is smaller, right? So corresponding term is smaller. So let bn is equal to 1 by n square. 1 by n square. So then an is less than or equal to bn and basically non-negative for all n. So we know that series bn, which is 1 by n square, is convergent, right? And therefore series an is convergent, right? Because the an is a smaller actually, but here we are assuming positive, not in general, not in case of negative numbers, right? So this is clear. Now look at
Yes, sir.
so look at the series 1 upon n square minus n plus 1. N is from 1 to infinity. Okay, so what is an here? Nth term of series n square minus n plus 1. But I cannot say that this is less than or equal to 1 by n square. This is not true. Why? Because denominator is minus. If you neglect minus n, then that corresponding number n square minus n plus 1. This number is less than or equal to n square plus 1, or this is less than or equal to n square. But this is not useful because of, then what will happen? N square is less than or equal to 1 by n square minus n plus 1. This is not useful. We know that smaller thing is convergent, but from that we cannot say that keep larger thing also converge. If larger thing converge, then smaller thing converge. That is clear. But if smaller thing is converging, then larger may not be. It is larger anyway. Right? So this is not useful. Do you understand why it is not useful?
Yes, sir.
Right. So therefore we need to have some different technique. So what could be the another technique so that we can so observe that 1 upon n square minus n plus 1 is less than or equal to 2 upon n square. Why? Why? Because n square, just check cross multiply n square and 2 times n square minus n plus 1. Which quantity is smaller? Is this
N
quantity?
square is smaller
Right. Why? Do you understand the reason? Do you understand the reason? Why smaller?
because if we open the bracket, we can write it as n square plus n square minus 2n plus
Right.
1.
So n square, uh, 2n square minus 2n plus 2. Just think about it. Or n square plus 2n and 2n square plus 2. Right. So n square plus 2n is less than or equal to 2n square plus 2, and just go in reverse way. Right, you will get this, and therefore this is one way, but here we need some trick how to actually get this. There are many other techniques possible. This is one way. If you just start with this, say go this to this. Now if bn is 2 upon n square, then bn is convergent. Am I right?
Yes, sir.
Right, because bn is just 2 upon n square and 2 summation 1 by n square. So this sum is finite. If sum is finite multiplied by 2, still it is finite. Right, and therefore an is convergent. This is one reason, but actually there is another test. So this test is limit comparison test. And this test makes life easy because easily we can understand. We don't need the tricks like this if you use this test. So limit comparison test. So what this test says, uh, suppose an and bn are sequences of positive numbers. Right, so I am assuming positive numbers. When I have a sequence, if I add all the terms, that becomes series, right? So uh, let what I should say, L is equal to limit an upon bn. Right. Now, do you understand what I mean to say an upon bn? Right. Suppose you have a sequence an is equal to 1 upon n square and bn is equal to e raised to n upon log n, like this. Then what is an upon bn? An upon bn is log n, right, upon n square e to the power n. So this is again a sequence, right? If a and bn are sequences, an upon bn is a sequence, and limit of this sequence is L. Now if L is not equal to 0, if this limit is not equal to 0 and it exists, right, limit exists and it is not equal to 0, then an is convergent if and only if bn is convergent. What does it mean? If this limit exists and non-zero, that is, if limit is non-zero, then either both an and bn, series an and bn, are convergent or both divergent. Right? Do you understand the importance of this expression, this test? If you calculate limit of an upon bn and it is non-zero, it exists and non-zero, and if you know the bn is convergent, then you can say that definitely an is convergent, because one of them is a simple series, right? If one of them is a simple series and we know the convergence or divergence of one of them, then same is for another, provided this limit is non-zero. Right, and therefore this test makes our life easy, because just from convergence or divergence of one series, we can state the convergence or divergence of another series. And second observation, if this limit is 0, then uh, Bn is convergent implies An is convergent. So if Bn is convergent, whatever is the denominator Bn, if that corresponding series is convergent, then the whatever is numerator En, so corresponding series is convergent, provided limit L is 0. This is how the test is. And this can be proved, but before going to proof, we'll see examples. Right. So consider previous example, 1 upon n square minus n plus 1. Right. We observe by some previous calculation, okay, this is convergent, but suppose we don't know any trick, so an is what? 1 upon n square minus n plus 1. Right. Now, can I produce or can I find another sequence Bn, a series Bn whose convergence is known, right? So that and limit of an upon Bn is exists, right? So let what is a proper choice for Bn? So here I will take Bn is equal to 1 by n square. Why I am taking this, that we'll discuss later on. Right, so let Bn is equal to this. Now, therefore, what is An by Bn? Let us calculate this. An is n square minus n plus 1 whole divided by 1 by n square, which is Bn. So this is n square upon n square minus n plus 1. Can we simplify this? Is there any simplification so that you can evaluate the limit? Yes. Okay, is it correct? Whatever I have written is.
Yes, sir.
Yes, sir.
So we can take n square outside so that I will get simple expression an upon bn is 1 upon 1 minus 1 by n plus 2 by n square. And therefore, what is limit? So this is a new sequence actually. And what is limit as n tends to infinity? An upon bn. So what is it?
1.
1.
1.
Right. So 1 minus 1 by n plus 2 by n square. And ultimately this limit is 1. So therefore here L is equal to limit of an upon bn is 1, which is non-zero. Therefore, by limit comparison test, either both an and bn converge or both diverge. Right? If you know convergence of one of them, same is for another. And do you know any one convergence of bn? What do you know about bn?
It is convergent.
Convergent.
Convergent. And therefore same is for an. And hence an is convergent. So an is n square minus n plus 2 is convergent. Right. And therefore the here trick is ki we have to choose a proper bn which whose convergence is known, so that we'll get a limit which is non-zero. Right. So for example, if you look at series n square plus n plus 3 divided by n raised to 4 plus n plus 2019. Now what can you say about convergence of this series? So here, what is an? An is what? N square plus n plus 3 upon n to the power of 4 plus 2020 n plus 2019, whatever is it. Now note that limit of an is 0, but this is not useful for us, right? Limit an is 0 is not useful, because if limit an is 0, series may converge, may diverge. If limit an is non-zero, then certainly series is divergent, but this is not useful. And therefore we want to produce series Bn whose convergence is known. So I will select here Bn is equal to 1 upon n square. Right. Then what is an upon Bn? What is an upon Bn? N square plus n plus 3 upon n to the power 4 plus 2020 n plus 2019 divided by Bn, that means n square upon 1. Now you can take n square outside from the numerator, n square, this n square, and what remains? 1 plus 1 by n plus 3 by n square will remain in numerator, and in denominator take n to the power 4 outside. What remains? 1 plus 20 by n cube. So 2019 divided by n to the power 4. So this n square and n to the power 4 cancels. And now you tell me what is the limit of
1.
1, which is non-zero. Therefore both converge or both diverge. Therefore both an and bn converge, or both diverge. But we know convergence of Bn is convergent, and hence An is convergent. Right. So same is the both same is for both of the series, and once we know convergence of one of them, same is true. So here, how do I select Bn? To select Bn, uh, Bn is equal to n to the power p upon n to the power q, where what is p? How to select p? So p is equal to highest power in numerator of a. Right, look at the numerator of a, and what is the highest power of p in the numerator of a, and what is q? Highest power of n in denominator of an. Is it clear? Is this clear what I am saying?
Yes, sir.
So in previous example, what is the numerator of an is n square plus n. What is highest power? N to the power 2. So in this case p is equal to 2. And what is q? Highest power of n in the denominator 4. And therefore I select n to the power 4. So this is 1 by n square. That's why I select here bn is 1 by n square. Is it clear? Right? So this is uh, one test which is useful for us, right? So if series is convergent, right? If we take absolute values of terms, then we say that series an is absolutely convergent, right? Absolutely means if you take absolute values of terms. So if series an is absolutely convergent, then series an itself is convergent. What does it mean? That is, if you take absolute values of terms is convergent, then if you don't take absolute values, then also is convergent, right? If you take absolute values, then and it converges, then if you don't take absolute value, then also it converges, right? If series an is convergent, but if we take absolute values of series, then it's divergent, then we say that series an is conditionally convergent. Then we say that series an is conditional. Conditional means basically series is convergent, but if you take absolute values, then what happens? Okay, so to understand this, there is one more test, alternating series test. So alternating series test. So what alternating series test? Suppose AN is a series of, suppose uh, AN is a sequence. Okay, don't. Okay, let me state in simple way so that. So what test is? Suppose A1, A2, A3, AN, AN plus 1. That means terms are decreasing. Right? Terms are decreasing. And second, limit AN is equal to 0. Right? Okay. Let me add one more sentence before this. Because under what condition test is applicable, that you should remember, not in general. So if my terms are positive, suppose AN is a sequence of positive numbers such that A1, A2, A3, AN, AN plus 1, so decreasing, and limit of AN is 0 as n tends to infinity. So all ANs are positive basically and they are decreasing, right? And limit of AN is 0. Then the series minus 1 to the power n plus 1 AN, AN is from 1 to infinity, is convergent. Why it is called as alternating series, right? So why it is called as alternating? Because terms are alternate plus and minus. For example, let AN is equal to 1 by n, right? Then can I say that AN is positive for all n? Is it true? Yes. Is it true that AN is positive for all n? Yes. Can you hear me? Yes. Can you hear me or you can't hear?
Yes, sir. Yes.
Okay. So AN is positive for all n. Is it true that A1, A2, A3 terms are decreasing? That means, are these terms decreasing? Is it true?
Yes, sir.
Now third condition, what is limit n tends to infinity AN? What is it?
0.
0.
Now in alternating series test, does all the conditions are satisfied? All terms are positive, terms are decreasing, limit AN is 0, right? So then what is series minus 1 raised to n plus 1 AN? What is this series? Minus 1 raised to n plus 1 upon n. What are these terms? What is the first term? N is from 1 to infinity. What is the first term? 1. What is second term? Minus half. Third term 1 by 3 minus 1 by 4, 1 by 5, and so on. So why this series is called as alternating? Because terms are alternate, plus and minus. Right, is convergent. Right, so this series is clearly convergent by alternating series test, because all the conditions of this test are satisfied. Yes, is it clear? Now
Yes, sir.
look at another series, root n. N is from 1 to infinity. So is it convergent? Now you tell me, is it convergent? What is an? 1 by root n. Right, I am taking an means the factor 1 by root n. Right, then is it positive for all n? Right, alternate sign is due to minus 1 raised to n. Right, so an is greater equal an plus 1 for all n. This is true. Second condition. Third condition, what is limit of an? Limit of an is limit of 1 by root n is 0. Right, and therefore series minus 1 to the n an, which is minus 1 to the power n root n, is convergent. Right, so it is, so this series, right, so this series is called as a harmonic series. Series minus 1 to the power n plus 1 upon n is called as harmonic series. And why it is harmonic series? Because this series corresponds to harmonic oscillator. Right, and if you study harmonic oscillator, then you will see such kind of things. Ki 1 minus half plus 1 by 3. So oscillator oscillates from left to right, right, in that way, and how much length it covers, that you can understand. Correct. So this series is also convergent because by alternating series. Why that proof is a different thing, right? But it is not difficult to prove it. Basically, you can certainly prove. So, what can you say about this series? Is it convergent?
Yes, sir.
Right. So you just look at an. An tends to 0, and ans are decreasing, and therefore the terms are alternating. So series is convergent. Right, and therefore you have to you observe very simple things, and you can easily understand ki, okay, this is convergent. Certainly it is convergent. This is what alternating series test. Now consider series. What can you say about series 1 upon root of n plus 1? N is from 1 to infinity. So what can you say about this series? What is an here? 1 upon root. This is not alternating series, right? All terms are positive, so not alternating. But what can you say about this series? Is it convergent or divergent? And how will you prove by comparison test? How will you prove it is divergent by comparison test? So what is the proper choice for Bn? By limit comparison test, what should be Bn? What should be Bn? Yes. What is the power of n here? Half in an. So I should choose Bn 1 by root n. And therefore what is an upon Bn? Correct?
Yes.
And then what is limit? correct?
1.
What is 1? So limit of an upon bn is limit of this, which is 1. And therefore both converge or both diverge. Therefore both an and bn converge or both diverge. But we know that series 1 by root n is what? What is about this series?
Divergent.
Divergent by p series test, and therefore root n plus 1 is also divergent. So certainly it is divergent, right? So you can have, we have already discussed that this series is convergent, right? 1 upon n factorial. We have already discussed because corresponding sequence of partial sums is monotonically increasing and bounded above, therefore convergent. Now, what is a simple observation here? So, 1 upon 1 is less than or equal to 1 by 1. So, 1 upon 2 factorial and 1 upon 2 square, which quantity is larger and which quantity is smaller? Here it is larger, right?
1 by 2 factorial is larger.
Right. So, but if you go further, 1 upon 3 factorial and 1 upon 3 square, here it is 6 and here 9, still it is larger. 1 by 4 factorial and 1 by 4 square. Now, which is larger? 4 factorial is
1 upon 4 square.
right, 1 upon 4 square. And you observe that key 1 upon n factorial is less than or equal to 1 by n square for all n greater equal 4. 4 onward this is true. And by comparison test, key first few term doesn't matter. First few term doesn't matter. So therefore and 1 by n square is convergent. Right? Here k is 4. K on n on 4 onwards, this 1 by n factorial is smaller. Therefore, can I say that 1 by n factorial is convergent? Right?
Yes, sir.
Now, simple observation. Suppose we know that 1 by n square is convergent. Right? Basically, what is this series? If is one is from n is from 1 to infinity, so this is 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. Right? These are the terms of this series. Now suppose I consider another series 2000 plus 5000 plus 1275 and then 1 plus 1 by 2 square plus 1 by 3 square and so on. Same pattern. What can you say about this series?
It is convergent.
Still convergent because uh, if you look at this number, this is some finite number and we already know that this infinite sum is finite number and this is also finite number, so this total is finite, is convergent, right? Therefore first few terms is not a matter, not a problem, right? What happens before k, not an issue because only finitely many terms, that sum is finite. What happens after k? That means after k there are infinitely many terms. If that sum is finite, then total sum is finite, right? This is what it means. So okay, now uh, From our previous discussion, minus 1 raised to n plus 1 upon n, is it convergent? Right? Is it convergent?
Yes, sir.
Yes, sir.
Now, but if you take absolute values of the terms, what is it? What about this series?
Divergent.
It is divergent. Because in alternating series, some terms are minus some, so some part get actually eliminated and some remains finite. But if you take absolute value, that means all terms are positive, then it is divergent. So therefore, by our previous definition, this series is convergent. But absolute value series is divergent, so is conditionally convergent. Am I right? Is conditionally convergent. This is an example of conditionally convergent series. Now, what about upon n square? Is it convergent?
Yes, sir.
Right, by alternating series test, it is convergent, no doubt. Also, if you take absolute values, what is it? If you take absolute values,
Convergent.
1 by n square is also convergent. Right, that means series is convergent. If you take absolute value, then also convergent. So series is called as absolutely convergent. Therefore, minus 1 raised to n plus 1 upon n square is absolutely convergent. Is absolutely convergent. It is not necessarily true that if series is convergent and then if you take absolute values, then also it is convergent. This is not true. Right. Okay, now consider sine n upon n square. What can you say about this series? Is it convergent? Is this sum finite? Yes. Here an is sine n upon n square. Correct? Yes.
Yes, sir.
Okay. Now can you compare with some another series? What is absolute value of an? Right? Absolute value. It is less than or equal to 1 by n square. Am I right?
Yes, sir.
And series 1 by n square is convergent. That we know. Therefore, bigger series is convergent. Therefore, can I say that sine n upon n square absolute value is convergent? Can I say? Because whatever is this absolute value of sine n upon n square, whatever it is less than or equal to 1 by n square, and 1 by n square series is convergent. Therefore, this is convergent. Yes. But from this, can we say that an, which is sine n upon n square, is convergent? Yes. If we remove absolute value, then also it converges. Right? If absolute value series is convergent, then if you remove absolute value sign, then also it is convergent. That is what the it says. Is it clear? Whatever I am saying is clear.
Yes, sir.
Yes, sir.
Right. So, series cosine, is it convergent? This is first question. Is it convergent? What is an here? Cosine. And what is limit n tends to infinity cosine? What is limit as n tends to infinity cosine?
0.
No.
1. 1. Sorry, 1.
How it is 1? Does not exist. Because if you see the graph of cos, right, as n increases, the values of cos is oscillating actually. The proof is not easy at this, but it is divergent. This limit does not exist actually. Similarly, limit n tends to infinity sin n does not exist. Remember this. Why? We may discuss this later on, but remember limit, and simple reason is because of the graph of sine and cos. If you go further and as n tends to infinity, it is not going to settle at any particular point, right? Graph is going up and down, so corresponding values sine n and cos n are also oscillating, right? That is actually happening because the functions are oscillating. So same is for sine and cos. So limit does not exist, and therefore, if limit of an does not exist, what can you say about series an? What can you say
It is
about
divergent.
divergent? And therefore, what is about series cos n upon n square? But this series is convergent, right? Why? By the similar to the previous. Cos n is divergent, but if you multiply by n 1 by n square, it is convergent. So similar to the previous discussion, what we had. Right. So there is one more test, Cauchy's nth root test. So Cauchy's nth root test. Suppose n is greater equal 0 for all n. Suppose all terms are positive. Let L is equal to limit n tends to infinity an raised to 1 by n, nth root, or limit n tends to infinity nth root of an. Right, so let us take this as a limit. Now if L is greater than 1, then series an is divergent. Second, if L is less than 1, then series an is convergent. Third, if L is equal to 1, then test fails. Test fails means may converge, may diverge. No information is obtained from this. Now statement is clear. Statement is clear.
Yes, sir.
Right. So you have to just evaluate the limit and see what happens. For example, consider the series 2 raised to n upon n raised to uh, 2 raised to n upon n raised to n. Right. So now does this series converge or diverge? We want to check this. So what is an here? 2 raised to n upon n to the power n. Now what is an raised to 1 by n? 2 to the power n upon n to the power n raised to 1 by n. And what is it?
2 by n.
2 by n. And therefore what is limit n tends to infinity 1 by n? So limit n tends to infinity 2 by n. This limit is 0, less than 1, correct? Less than 1. And therefore the series an is convergent. Now you can apply this to the known series whose limits you already know. For example, 1 upon e to the power n, which we have already discussed, it is convergent. But let us apply this test and check whether this test gives the same answer. Right. So what is an? 1 upon e to the power n. And therefore what is an raised to 1 by n? What is an raised to 1 by n?
1 upon e.
1 by e, which is constant now. And therefore what is limit n tends to infinity an raised to 1 by n. So 1 by e, and 1 by is less than 1, right? Therefore series 1 upon e to the power n is convergent. So here if your expression contains powers, right, expression or indices contains n, then this test is useful. Immediately we'll get simple expression and we can understand the convergence or divergence, right? So for example, okay, for example, okay, there is one more test, but for what values of x, the series x to the power n upon n to the power n is convergent, right? So for what values of x this will converge, right? How will you do this? Here an is x to the power n upon n to the power n, and I will look at a raised to 1 by n. Basically this test is for positive, but if we take absolute value then also no problem, right? So what is it? X to the power n upon n to the power n raised to 1 by n. What is it? Yes. And what is limit now? Correct?
Yes,
Yes.
sir.
And therefore no matter what x you select, therefore is always convergent for any x. Right. This is very interesting thing. Whatever x you put in that case, no problem. Every time limit comes out to be 0 less than 1. So the series is convergent. So, okay, we'll stop here because we have next lecture. But there are some more tests, and using those tests you can understand the convergence or divergence. So you try to solve more exercises, more problems, so that you can understand it properly. So in next week we'll try to discuss problems or practicals on the topics which you have discussed, real numbers, sequences and series, so that will be helpful to you to understand or revise the concepts, right? And I will share with you practical sets and we'll discuss the questions solutions. so that that will be your revision also, and how to solve the problems. So both things will happen, and we'll see more tests during those sessions, right? So that you can have conversions of many series, right? So is it clear?
Yes, sir.
Yes. Okay, so whatever we discussed so far, you read it carefully. As far as our syllabus concerned, we have covered all the topics. But from next week, we'll discuss the problem solving or practicals. Our practical sheets will be shared, and that will be very helpful for your final exam, right? Okay, so any doubts?